Hello students, this is Mr. Yao. In this lesson, we are going to learn the last operation for complex number, and that is division. First, let's quickly review what we have learned before. Simplify. I to the 74th power minus I to the 35th power plus I to the 65th power. That one, we're just going to use the pattern that we have learned in the last lesson, which is every 4 of them, they're going to start repeating. First, 74 divided by 4, that is 18.5. It's a 0.5, so we know that is going to be the same as 2/4, because 0.5 is 2/4. So that means I to the 74th power is the same as I squared, which is -1. Next, 35 divided by 4, that is going to be 8.75. 0.75 means 3/4. So that means I to the 35th power is the same as I to the 3rd power, which is going to be -I. Next, 65 divided by 4, that is going to be 16.25. So 0.25 is 1/4. That means it's going to be the same as I to the 1st power, which is I. So the whole thing will become -1 minus a -I, then plus I. So it's going to be -1, that's a plus I plus another I plus 2I. That is the standard form. B. We're going to need the square root of 216, and it's a -5 in the front, so it's a negative sign outside the radical. There's nothing inside the radical, so we can just go for it. It's -5, and the 216 is actually going to be 6 cubed, or if you want to go more, it's 2 cubed times 3 cubed. So you can take out a pair of 2 and a pair of 3. It's going to be -30 square root of 6. Next, first it's negative to the 79th power, and then it's I to the 79th power. That is going to be -1, I to the 79th, so 79 divided by 4, that is going to be 19.75. 0.75 is 3/4, so it's going to be the same as I to the 3rd power. So I'm going to just times by I to the 3rd power, which is -1 times -I, which is just going to be an I. That is C. D. First, we got to rewrite that. That is the same as the square root of -1 times the square root of 16. So the 3 minus 4I times another 3 minus 4I. You can choose to make a log, so you can go directly to the answer. It's 9 minus 24I, and then plus 16I squared, which again, this turned into a -16. So the whole thing is -7 minus -4I, 24I. There you go. These are the things that we have learned in the last lesson. Now let's get into a little bit more review. Well, let's say you want to multiply these. And I had mentioned in the previous lesson, you might have noticed some examples. So let's quickly do this. 3 times 3 is a 9. 3 times a -4 is a -12I. 4i times 3 is a +12I. And then lastly, 4i times -4i is a -16I squared. So the middle two cancel. And then this becomes a positive because I squared is a -1. So it's a -16 times -1. So it's a plus, which is a 9 plus 16, and it's a 25. Okay, next one. 9 times 9 is 81. 9 times 4i is 36i. 4 times 9 is another 36i. And then lastly, 4i times 4i is a plus 16i squared. So it's 81 plus 72i. I squared is going to change into a -1, so -16. Final answer is going to be 65 plus 72i. The reason we're doing these two problems is for you to see when it's a plus and a minus. In the final answer, you only have a number. There is no I left. But if they're just the same sign, they're either both plus or both minus, you will have this I part. And this leads to something we have learned before, which is rationalizing the denominator. That's exactly how we divide complex number, just like how we divide before we have learned radicals. Our goal is to make sure there's no I left in the denominator. Just like when we divide the radical, we want to make sure there's no root in the denominator. So for here, we are going to use, if you forgot what that is called the conjugate. Because only if we have a plus and a minus, they are going to actually cancel with each other. So let's move on. Conjugate. A math conjugate is formed by changing the sign. between two terms in a binomial. For example, 3 plus 2i and 3 minus 2i. So as you can see, 1 plus, 1 minus. Okay, even if let's say you have negative 4 plus 3i, when you try to write the conjugate, it's going to be negative 4 minus 3i. The key is the sign in the front does not change, just the sign in between is going to be changing. That is the conjugate. The reason we work with the conjugate is because they can form this perfect perfect square binomial, which is actually the difference of squares. And after multiplication, the x square is going to be a normal number, and the y square, even though you have I square, they're going to change into just a -1, multiply with a number. So that will also be just a number without any I left. So that's why we need to use the conjugate. Let's have a look. We still have two types of questions. In dividing radical, let me quickly talk about the radical again. We had a type of question. One is, for example, you just divide by a square root of 5. Let's say it's a 2 divided by a square root of 5. You just need to multiply the top and the bottom by a square root of 5. And the other type is things get a bit more complicated. Let's say you have 2 minus square root of 5. That's the one you need to conjugate. Same thing with the complex number. The first type is you just have an I left, no real number part. Here we go. Multiply the numerator and the denominator by the conjugate of the denominator. For these, well, 4i, the conjugate is just negative 4i. However, you can just go very easy by multiplying everything with an I. That is going to 7i on the top and 4i squared on the bottom. So we're going to get 7i over negative 4. Simplify. We typically put the negative sign in the front, so it's negative 7i over 4. Or you can also choose to write the I outside is negative 7/4 I. Example 2, same thing. We're going to multiply the top and the bottom by an I. Okay, so even though the step is more for the more complex question. So, but your final answer still needs to be in A plus BI. For this, you can choose to remember them all together. If you actually want to use the conjugate, 4i has a conjugate of negative 4i. That won't complicate things too much. That totally works. But if you just multiply with I, that's actually easier. So in this case, negative 9i times I is negative 9i squared on the top. 1 times I is an I. Negative 6i times an I is a minus 6i squared. Let's start simplifying. On the top, I. This is a negative 6. I squared is negative 1. So negative 6 times negative 1 is a positive 6. On the bottom, negative 9 times the negative 1 is a positive 9. But since I need to write my answer as A plus BI, I actually need to separate everything. It's going to be I over 9 plus 6 over 9. But we also want the number in the front. So it's going to be a 2/3 plus 1/9 I, which means your A part is 2/3 and the B is 1/9. That's example 2. Moving on, the steps are given again. This time, since we have two separate things on the bottom of the fraction, we do need the conjugate. And again, the conjugate is the number in the front does not change, so negative 1 stays. We change the sign in the middle, so instead of plus 5i, it's going to be a minus 5i. So we copy the same on the top. There you go. So let's deal with the bottom. Negative 1 times negative 1 is going to be a positive 1. Negative 1 times negative 5i is going to be a positive 5i. Then 5i times negative 1 is a minus 5i. Lastly, 5i times negative 5i is a minus 25i squared. On the top, 7 times negative 1 is negative 7. 7 times negative 5i is a minus 35i. These two terms will cancel with each other. On the bottom, we have 1 is a negative 25 times I squared, which is a negative 1. So it's a 1 plus 25. Copy down the top. We can actually change the bottom now. 26. We do need to separate everything and simplify. So it's negative 7 over 26 minus 35 over 26. I. You can still choose to put the I on the top, but to be more precise with the form, I should be on the side. That is example 3. Now just a few more. Okay, example 4. Same thing, we need to multiply with a conjugate. Since it's already a minus 7i, it's going to be a 1 plus 7i on the top as well, 1 plus 7i. Okay, the more you do this, the more you realize, oh, on the bottom, it is just going to be the 1 squared, and then subtracting the 7i squared. So I'm still going to show you to make a box. 1 minus 7i, 1 plus 7i. So that is a 1, then it's a negative 7i, a positive 7i, lastly, minus 49i squared. Cancel. This is negative 49 times negative 1 is a positive 49. So the bottom together is actually going to be a 50. As for the top, let's do our multiplication. 5, negative 4i, 1, positive 7i. So it's a 5, and there's a negative 4i, and there's a positive 35i, and then 7i times negative 4i is a negative 28i squared. So we have a negative 4i and a 35i, that's a 31i. In the front, we have 5. This is a negative 28 times I squared is going to become a positive 28. So let's actually separate them. 33 over 50, nothing to simplify, and plus 31 over 50, I. There you go. That is example 4. Moving on, example 5. 6 minus 6i. And on the top, same thing, 6 minus 6i. Let's do the box. 6, negative 6i. And another 6, negative 6i. 6 times 6, 36. Then we can ignore these two. Negative 6 times negative 6 is a positive 36, so it's a 36i squared. So we're going to have, oh, actually I wrote it wrong. It's a plus, so it's actually going to be a negative 36i squared. So it becomes a 36 plus a 36, which is a 72. So let's put that as the bottom of the fraction. Okay, let's deal with the top. 6, negative 6i. Then it's negative 3 and a 5i. Negative 3 times 6 is negative 18. Negative 3 times negative 6i is a positive 18i. 5i times 6 is 30i. 5i times negative 6i is a negative 30i squared. So first, numbers, we have negative 18. That's a negative 30 times I squared is a positive 30. So it's a 12. Okay, and keep going. We have a 30i and an 18i, so it's a 48i over 72. Let's simplify the fractions. Become 1/6 plus 48 over 72 is a 2/3 I squared. Just I. There you go. Last one, example 6. Times by a negative 2 plus 3i, negative 2 plus 3i. On the top, well, I'm just going to deal with the bottom real quick. Negative 2 squared is a 4, then minus, so it's a 4 minus 9i squared, which is going to be a 4 plus 9, which is 13. So the bottom is going to be 13. As for the top, negative 3, negative 2i, negative 2, positive 3i. So it's a 6, then it's a 4i, then it's a negative 9i. 3i times negative 2i is a negative 6i squared. So let's see. The bottom is 13. The top 6 is going to be a 6. Negative 6 times negative 1 is another 6, so 12. And then 4i and negative 9i, we're going to have a minus 5 over 13i. And that is the final answer for number 6. So hopefully you have seen some resemblance compared to the dividing radical lesson. They work really similarly. That is everything for this Rationalize the Denominator lesson. Thank you.